Welcome to BFOIT's Introduction to Computer Programming website. This is a short screencast overview of the first lesson. What is computer programming? Computer programming is composing or authoring of a process or procedure for doing something, but in incredible detail. In a more advanced world, science fiction today, it will be possible to teach the computer to do something by describing what it is that you want in your native language, English in my case. But as of now, this is pretty much fantasy. Why? This lesson contains an experiment that you can perform which demonstrates why. Participants in the experiment write procedures for how to make a peanut butter and jelly sandwich. Then, someone plays the part of a computer and tries to perform the procedures. When this is done properly, it demonstrates how much information is assumed in normal human communications. Think about it. Computers have absolutely no common sense. So if we can't program a computer in our native language, how is it done? Almost all the computer programming these days is done with high-level programming languages. For BFOIT's introductory lessons, we start with the Logo programming language. Logo has early ties to MIT, Massachusetts Institute of Technology, and a scientist named Seymour Papert. It has a low floor and high ceiling, which means it can be learned easily, but is quite capable. It is a derivative of the Lisp programming language, which itself has been around since the 1950s and is still used today to explore very complex stuff. As an example, research in the area of artificial intelligence. Let's look at some examples of programming a computer in Logo. Our first program simply introduces itself. It prints out Hello World. A slightly more complex program prints the result of multiplying a random number in the range of 0 to 14 by 10. As you can see, if we do it again, we get a different result. That's the random part of this program. Finally, we have a program that's complex enough that we have to create it in the editor that's provided. It's a function named getMax, and it outputs the largest number from a list that it's given. When I invoke getMax with its proper inputs, I get the result that you'd expect. As you can see, the Logo programming language is sort of like English, but not quite. It's got square brackets and colons where you don't expect them, and the ordering of the words seems a bit strange. These differences are important. They make it easier to translate what we want done into the language of the computer. Below the level of programming languages, one step above a computer's native language is what is known as assembler language, where everything is given human-friendly names. A programmer works with operations that the microprocessor knows how to do, but they have names. The microprocessor's registers and addresses in the computer's memory can also be given meaningful names. Remember our Logo getMax example? Table 1.1 contains a similar program written in assembler. It locates the maximum number in an array, where an array is a group of numbers in sequential memory locations. Take note of the comment column. The remarks in it are only for humans. The computer ignores them. Before I can show you what a computer's native language looks like, let's look at what it contains. Bits. A computer successfully creates the illusion that it contains photographs, letters, songs, and movies. All it really contains is bits. Lots of them, patterned in ways you can't see. Think of bits as light circuits, like the ones in figure 1.1. A bit is either off, which means it is a 0, or it is on, which means it's 1. Since a single bit is quite limited, computers manipulate groups of bits. In the next 3 sections of this lesson, I go into detail describing how bits are used to represent numbers, ASCII characters, and pixels. So, a computer's native language must also be bits. But how? Well, each instruction a computer can perform is identified by an opcode, which is short for operation code. An opcode is just a number. Instructions and the things they operate on are in memory, and each location in memory has an address, which is simply a number. Like your brain has working memory, microprocessors have registers for quick access to stuff. They are also addressed in instructions by groups of bits. Yes, the language a computer understands is just bits. Here is a robot computer simulator you can explore if you're interested. As I said at the start of this lesson, programming is just describing how to do something. But since computers don't understand our native language, and we would go crazy trying to describe something with just ones and zeros, which is what the computer does understand, we use computer programming languages. In the following 18 lessons, you will learn the basics of computer programming. We will work together writing programs in the Logo programming language. It should be fun. When was the last time you got to play a game as an exercise? Here's a game that will help you get good at working with binary numbers. Try it out. And finally, for some more interesting reading, here's a great book, Blown to Bits. It's free on the net.